Okay, for today's video, what we're going to do is some testing between the Bridgeport and the CNC machine out in the other bay. What we need to know, or what I need to know for a project that's coming up, is if I very accurately, as accurate as I can, drill for a dowel hole on the Bridgeport, does it match what I can do out on the CNC? I need a light press on the dowel on one side, and a very tight tolerance slip fit on the dowel hole on the other piece. And then these pieces have to go together. So it's just testing the accuracy of the DRO and the Bridgeport versus the accuracy of the glass scales on the new Cincinnati CNC machine. So let's get busy and see what happens. Found a couple of nice chunks of 3/4 inch thick cast aluminum. These are some cut-offs from a previous job. The astrometric camera job. I believe the video for making some of the stuff at least is I'll link that probably up here or something. Anyways, we got to go ahead and square these up on the new badass dual saw. So let's get busy with that. It's a little bit of moderately high-speed sawing, but I don't know. Got it set at 2,000 RPM. The dowels I've chosen are going to be these long 3/8 guys, and this is just a McMaster-Carr kit. Comes right out of that slot. We're going to be final reaming with an old school set of Laval over/under reamers. So those of you that don't know, this is thou under, thou over. So you can get a slip fit and a press fit, or a press fit and a slip fit, sorry. So yeah, maybe the first one we'll ream with a press fit, and we'll punch these dowels in. Okay, going back to my my video about measuring tiny things, and I know I got some of the numbers on the titles all screwed up. You guys know what I mean. Sorry about that. I'm not going to go through and correct that. If I get any more flack about it, I'll just delete it. Anyways, how big is this dowel? This says it's just a hair oversized. If we stick it in here, and I have zeroed these. So there we go. 2.5 tenths over. Let's get another one. I have found that these McMaster dowels are pretty high quality. I mean, you can't beat that for consistency. Really amazing. Okay, on the Bridgeport, we've got our piece of material that we just cut off. This is the saw cut edge. That saw does such nice work that I can pretty much just stick this right in the. I'll put the as provided edge toward the back of the vise. Not really important. All we're concerned with is punching a hole from a set distance off of a machined edge. I think we'll go 1 inch, and then we'll punch another hole. All right, got some parallels. Whoop. Said I was going to put this edge toward the back of the vise. Going to go ahead and swap out this this chuck for 1/2 inch end mill. And we'll go ahead and raise the table up. And go down to the end. Okay, what we're going to do here is just face off this end. Okay, now what we want to do is pick up this edge right here and make that 0. And maybe I'll pick up this back edge, the factory finished edge, and just come in about half the distance. It's not really that important. I want to be able to sit this on the granite and measure to the top of the dowel and find the center hole of the dowel that way. And then measure the next dowel hole and see how far apart they are. If I can measure the difference between the Bridgeport and the CNC machine. Now we've got a number of different ways that we can edge find, and one of them is this optical edge finder right here, and I've never used it. So loaded it up with fresh batteries. We're going to go ahead and compare the difference between the optical edge finder and the old traditional edge finder. This ball is 400 thou diameter, so that means I'll have to come over 200 to find the actual edge. And then of course, like all of these guys, I think this is a Starrett. This one's 200 thou, so I'll have to come over 100 after I find the edge, and we'll show you how that works. Okay, I'll do my best to stay out of your way. We'll load this guy up. It's a 3/4 inch collet. Like I said, 400 thou on the tip. Make sure it's clean. There. And I'll just slowly move that over until we see the light. There it is. Boom, right there. Seems to be repeatable. I'll 0 that. Very repeatable. Okay, now we'll see if the old traditional edge finder backs up the number. Okay guys, it's been shown 100,000 times before, but this is how you use this guy. I like to start with just knocking it off center, and then you slowly creep in. I'm cranking the dial until you can hear the part hit, basically. And then it starts to square this guy up, making it concentric. And then once it shoots off to the side, that is the edge. I'm turning the handle real slow. Real slow. Barely budging it. Right there. And what you can see is I'm not real impressed. You know, that number should be 100, so we are 1 thou off. Don't like it. So what we're going to do is set this to 0. We're going to check it again by, see if this guy will focus, by backing off. Let's turn it 1,000 RPM, coming back real slow. Boom, right there. And I'm within a 1/2 thou. Check it one more time. Boom. Right there. It was teetering between a 1/2 thou and 0, so we're gonna run with that. That's our 0 point. Well, hold on. The other part is we have to get this guy up off the work and then move half the diameter of the probe tip. Probe tip's 200. We move it 100. There's our 0. Alright. Now I'll go ahead and find about halfway across this thing, and we're going to move in 1 inch and we'll start drilling. Alright, we got a chuck. We got a nice Jacobs chuck installed, and we are sitting 1 inch in, and I set 0 to basically the center line of the part. So we're 1 inch in. Table's locked. And here's what we're going to do. We're going to do a center drill, a small drill. I don't even know what size it is. We're going to step it up a bit to this guy, and then we're going to use this. I don't know. I was always told this is the most accurate way to do this. This is an undersize, freshly ground end mill, like 0.362 diameter, some random diameter. But it is smaller than this by about 10 thou. So, and then we're going to follow up with a reamer, which was a 374 reamer, and that should give us a nice press fit. So here goes that process. Sorry about my hand. Now we're going to go through this guy. Okay, gonna chase that hole out a little bigger now. I gotta move the table down a little. There we go. Sure I'm not up on the flutes here. There we go. This one I think will lock down a little bit. guy off. There we go. Okay, now, yeah, it looks like we can put this in a collet, so we're going to do that. See what collet size is required. Looks like 3/8. We'll send this down as deep as it'll go. And again, I gotta move the table up for this. All right. I'm gonna go ahead and give it a dab of oil. Help clear those chips. With a hole straightener. And now the reamer. And for this, the tail's got to go back down. Sorry about that. Gonna leave it nice and long so it can find the hole on its own. All right. We're gonna go in low range. Looks about right. We'll give it a bunch of lubricant. And the way I've always been told is to get in and get out. Just like that. Okay, now what I'll do is go ahead and do this on the next hole. Alright, so what I had happen on the time lapse that you'll see is that that end mill was actually ground different sizes on the opposite ends. So I cut this one a little too big, so we moved it 1 inch over. So now we're 9 inches from hole to hole center, according to the DRO on the Bridgeport. So now all I'm going to do is just take a little chamfer tool and just knock that edge off, both sides. So that dowel will want to go in nicely. Something to note on these dowels is that this edge right here is a bit sharp. So what I like to do is just take that edge off just a little bit, just round this a little bit on the end that I'm going to press in. That will prevent that from kind of cutting its way in and finding its own hole. It'll keep things straighter and be more consistent in your results. Now these are inch sizes, and these dowels typically are very different than metric. Now this is a metric dowel, and you'll see that it's got a fabulous lead in on one side, and then it's a bit rounded on the other side. So this would be the side you'd press, and this is the side that would be the slip fit. Okay, we're out at the arbor press. It's a Dake, one of my favorites from near the hometown, Grand Haven, Michigan there. It's a Dake #1. This thing's been beat and beat and beat through the years. You can see up here somebody's had a hammer on this thing. But yeah, still a good arbor press. So what you can see is over here. That was the hole that got a little big with the wrong end mill, and that's the correct size for a nice press fit. So what we'll do is go ahead and press into these two outer holes here. Now, because we rounded that end off, that dude's just going to go find his center of that hole really well. So there's that one. And now we'll do this one. I'm not using any oil on this. It's a pretty light press fit. No intentions of removing this stuff. So there we go. Boom, right down to the bottom. Okay, we'll go ahead and zero our height gauge out. Looks pretty repeatable. So, center of the hole is 1 inch. Half of 3/8, 0.375 is 3/16. So that should be 1.1875. And I'm actually quite shocked. 1.191. 1.190, 1.191. It's right in that neighborhood. So that's interesting anyways. Shows I need to do a better job. So I've learned something there. So now what I'm going to do is zero this. Sorry, I had to take a break there for the air conditioner. But we've got this zeroed now, and now I want to run up to the top of the other dowel and make sure that they're 9 inches apart. So here we go. I'm going to have to move the camera for you. Okay, and we'll come down on this guy. Okay, so the number really doesn't matter, but what I did was I drove to 9 inches, and of course we already had an inch on the bottom side down there, so that makes the holes 8 inches apart, and we are off. It looks like 1 thou. So that's interesting. I am rather shocked that I was unable to hit 1 inch. You see that original number. All right, so I'm going to go ahead and jump on SolidWorks here, and we'll go ahead and design up this this little part. I'm gonna draw the holes undersized, and then what I'm gonna do, I'm gonna interpolate the holes. So either a ramp or I don't know, a contour. Probably ramp them in, and then I'll do a contour finish cut. And I'll keep stepping it up. I'll increase the size of the tool, and I'll keep stepping it up until I get a beautiful slip fit on those dowels. And I think that'll be the plan. So I'll probably draw those in at, let's go ahead and extrude this guy here, and we'll pop in 3/4 like that. And now we'll make some holes there and there. 0.37 will probably be fine. Oop. 370, there we go. 370, and now I want to go ahead and put that one 1.0 from there, and this one we want to be 7 inches. All right. Oh no, we want that to be 8. 8. There we go. We'll extrude cut that. Through all, done. There we go. Now we'll go ahead and save it and go out and cut it. All right, I got our part clamped in, and too small. We're gonna go ahead and grab maybe like a 3/4 to surface that off. I'm not gonna do it as part of a program because I want the worst case, like it's an already finished edge, and I have to come in and pick that edge up to cut that hole, so we can test the accuracy of this hole setup, my repeatability and accuracy in the CNC machine. So we'll go ahead and enter tool 3. That's a 3/4. So I can start. There it is. And I'm going to go ahead and hand cut this, so I'll just enter like 2500 RPM, and then I'll just hand wheel this across and do the cut that way. Okay, there we can see the cut. Feels pretty darn good. I mean, it just took off dust basically. I was spinning the thing way too fast. So we'll go ahead and pick this edge up, pick this back edge up loosely, and that will establish the part. And the rest will be just interpolating the hole and then doing a contour cut to bring it to size. All right, we got the 3D taster in, and in the CNC, this is how I pick up an edge. So I'm moving it, I don't know what I'm moving in. Which increment? I think it's 1 thou. Yep, 1 thou increments. So let's bring this guy in. Now we're moving in 1/10 increments. And that's pretty close. Now I'll go ahead and set that to 0 and do the same on the Y. All right, we got the part loaded up in Mastercam here, and I've got a simple ramp contour that's going to cut down and zoom in right there. It's going to cut down in and make a pass at the bottom. I'm going 1/2 inch deep. I am leaving 5 thou on the walls, so it was a 370 hole, so that should make it about 365. So I've got right there, I've got my gauge pins out, and I've got a 365 gauge pin. Just as a sanity check, we're gonna, like I said, we're gonna creep up on this and see what we got. All right, I've sent the part out to the machine. If anybody's curious how it works on these Cincinnatis, all I do to retrieve it, transfer in, I browse, I stick everything in this folder. Whoops. Test, there it is. Okay, start transfer, and now I just run this program, and we can see made on the 25th at just before noon. It looks all right, and I can go down. I'm using a 1/4 inch flat end mill, 5500, just above the part. I go to 0, and then I start my interpolation. So we'll go ahead and run this and see what we end up with. So I checked it out there on the part, and it looks like a .357. This is a minus set of gauge pins. It looks like that goes in. And how does this pin actually measure? Pretty damn good. -1/10. This is the hole. That's our 357 gauge pin. It goes, and it's the kind of fit that I want. Yeah, nice and snug. And essentially we cut a 357 hole. Alright, we got the holes cut. It took a couple shots, but we are we're a good fit. So, nice tight slip fit. There's no movement in that whatsoever. All right, so I've pushed these I pushed these dowels into the holes. This is the part that was done on the CNC. used the 3D taster to pick up the edge, and then interpolated with a quarter-inch end mill, interpolated the hole and got it just right, just nice. A little slip fit, very tight slip fit, and so we'll see what this guy says. Again, this is centered 1 inch up, and half of a 3/8 dowel pin should be 1875. So 1 plus 1.1875. So see what the magic number is. Oh, look at that. That was right on. Beautiful. So my process in the CNC is solid. So let's go ahead and zero off of that, and we'll see where this top dowel sits. And again, I'll have to adjust for you guys. Just bumped it. Excuse the air conditioner. I'm going to call it dead nuts on. So there we go. Process on the CNC is very good. All right, now this is what we're dying to see. This is the piece off of the Bridgeport. This is the piece obviously off the CNC. This should slip right on there. Ooh. Of course, you got to go on square. Beautiful. All right, so here you can see the gap that was left, 1 inch up. So I think what I'm going to do now is go set this on the granite and put a machinist square on here, and we should see that this is not square, because that indicating off the edge on the Bridgeport was not as accurate as I wanted. So the pieces fit together wonderfully, but we still have to deal with that edge finding issue I have. And just to as a sanity check, I've got the two machine faces down, and the part is still doweled together. And I don't know if I can show this properly, but there you can see the gap. So I went through and popped another hole just as a tester. Same process on the Bridgeport. Indicated with the edge finder. Came up 1 inch, locked the table down. Drilled with the center drill, small drill, a little bit bigger drill. Followed it up with the end mill and then the reamer. And that's the hole right there. This time I left everything in the chuck, in the Jacobs chuck. I didn't do anything in a collet. So we'll see if there's any difference. Zero this guy out. This is the original hole. 191, very consistent. And this hole, So yeah, so there you go. I mean, I would have never guessed. I guess I've never even measured anything I've done on the Bridgeport. It's when I'm working on the Bridgeport, it's typically things that just aren't that fussy. But I am shocked. 2.5 to 3.5 thou off, kind of unrepeatable within a thou in those 2 holes I did. Gonna have to figure something out. Maybe I'll try buying some new edge finders. I don't know. I'm gonna look into it. If anybody out there has any ideas of what's more accurate, something to use in a collet, in a Jacob's chuck, on a Bridgeport, on a manual machine, let me know. Leave a comment. I don't know. The good news is that my holes are dead nuts between one machine and the other. The only issue I'm having is edge finding on the Bridgeport. So that's good. At least I don't have to worry about any sort of compensation or offsets over a certain distance. I know some DROs can do that. I'm not sure if that old guy can do it or not. But that's good that my dowel holes do meet up, and at least that process is pretty stable. So that's what we're going to do. Going to find out better ways to edge find in a manual machine. I hope this was informative. Maybe it gave somebody some ideas on how to check back and forth between manual and CNC. In the future, that's going to come up where that needs to be accurate for me and some of the work that I've got coming up here. So I'm going to keep pursuing that, and if I figure it out, I'll for sure let you know. Anyway, just over 300 subscribers. The channel's growing. Like, share, leave a comment, subscribe, do all that stuff. Let's keep this going, and stay tuned for the next video.